And yeah, Skip, jump off whenever you need to.
Cool. Thank you.
Yep.
Sorry, Eddie, I don't know what's going on with my video here. Can you see me?
I cannot see you. I can hear you, but I can't see you.
Probably a good thing. All right, let me try to fix this. Keep going.
Okay.
It is.
I think we're probably waiting on one or two people here. I'm gonna just run and grab some water, so I'll be right back, but give people a chance to get in here. And then, hey, for the Langers crew, Jack is with you all, correct?
Yes, he is.
Okay. And then Matt and Clark are joining us here tonight, and they'll be with your motley crew as well.
That's right. Yeah, Matt. I'm Matt. Hi, nice to meet you, Eddie.
Hey, nice to meet you too, Matt.
Matt, last night we all gave a 15-minute summary of our skiing experience and our goals for the class. So why don't you start now, which will take us to about.
Yeah, that's great. All right. Well, I started in the Junior Olympics at age 13, and it all went uphill from there. So get ready. About to blow your guys' minds on Thursday.
Oh yeah. Matt, one other thing I asked of everyone was what's like one primary goal for the course, or just kind of your reason you signed up for the course?
Yeah, I mean, I think it's just overall I shouldn't say level of comfort, but just sort of ability in the backcountry and being able to keep myself and other people safe, including my kids who are starting to kind of venture out, more side country stuff with them. But, I feel like I can find people and probe and dig them out, but I don't really have any experience assessing risk level. So that's what I want to be familiar with.
Cool. Thanks, Matt. Yeah, it's that's really the point of this course, right? Is to give you the tools to identify and avoid the avalanche hazard and understand like what the risk level is. In a nutshell, that's everything we talked about last night. And Clark, still can't see you.
Well, I don't know what's going on. So
That-
unless you need to
That's a
see
good
me,
thing.
which is not necessary usually for most people.
Yeah, no, as long as you can see us and you can hear us, we can hear you. That's all we need to work with.
I can see Shannon. That's all that matters. How you doing, Shannon?
Hi, Clark.
Clark.
We missed you.
Why don't you give us just a quick background of your background in skiing or riding and kind of reasons for signing up for this course?
Oh, well, let's see. All started when I was a small child. No, I've been skiing my entire life. Taught some skiing when I was a kid. Went to Boulder to ski. I like skiing. I don't know. What else is there to know? I signed up for this because Shannon doesn't want to go backcountry with me without being at least having some credibility. Chris is too late. Chris
That's
won't
fair.
go in the backcountry, so that's cool.
Totally.
Is that enough? I don't know. I
great.
mean, I think it's
Oh.
important, especially. I was just in Austria, and they had an inbounds avalanche that took out 20 people. Inbounds. So on piste avalanche. It was a little weird.
Yeah. Yeah, I saw a video of that. Were you there at that area or?
I was in that area. I missed it by a day.
Yeah, that was something.
Yeah. Yeah, kind of crazy. I think it freaked people out, especially
Yeah.
all the beginners who didn't want to, who were on that, who were on piste.
Yeah, I never I need to follow up because so for Clark and Matt, just a little bit about me. I work as a guide throughout the year. I've been, I guess, going on a decade of this work and teaching avalanche courses and kind of work all around the world. And then outside of guiding and instructing, I also work for a company that makes remote avalanche control systems. And it's interesting that incident in Austria, that ski area has a number of these types of systems up on that terrain where the avalanche released from.
Yeah.
And I know that they had done some control work that morning, and then sometimes during the day they had a post avalanche control release, like kind of spontaneous thing. So I don't know if it was it due to warming or
Yeah.
wind loading or something, so I'm curious to find out more about that. I don't know if you heard much.
It was really cold and then got really warm.
Yep, there you go.
And I think that's what it was. It was really cold about a week before, and then it warmed up. When we were there, it never really dropped below 0 Celsius. And so it was warm. It was probably 11 degrees Celsius at the peak sometimes. So it's pretty crazy.
Yeah, that it kind of, I mean, cool that you brought that up because that ties into a bit or quite a bit into what we're talking about tonight with we're going to get into snowpack and layering and what creates the instabilities that then create the avalanche problem. So
Yeah.
okay, let's see, we've got.
Sorry about the video. I don't know what's going on. It just was.
Oh, no problem at all.
We don't need to see you, Clark.
I get it, Skip. I get that. I don't need to see myself. It's better this way.
So I don't see, is Andre, you're not on here, right? There we go. Here he is. All right. We got everybody. Yeah, another thing, just while we're kind of on that topic, as we important to know if you are skiing or snowboarding out in Europe, it's a very different environment when you're in the ski areas. So they have a whole different approach to like risk management and mitigating for avalanches. In the US, typically any terrain that is accessible from the resort or overhead terrain that maybe threatens inbounds terrain is controlled to a very high extent. When you buy your lift ticket, you're often, if you read the fine print, you're kind of accepting the risk of avalanches. And we've seen through there's been a number of inbounds avalanche accidents that have happened over the years. Some fatalities, some with good outcomes. But the idea in the US is we basically bomb the hell out of everything. And that's part of what my other job involves, like selling systems so the ski areas and transportation departments can do that. But when you go to Europe, essentially they have the groomed piste runs, and off of that groomer, it's usually uncontrolled terrain, and that's maybe shifting a bit, but it's they have a very, I guess, different perspective on it. Sort of like you're accepting that risk as a skier and a user. And there was a pretty high profile incident, like forget the years, maybe 10 years ago, but it was some US ski team youth members, and they were over there, and the two of the racers skied off the piste, just ungroomed terrain right next to the ski run, and were killed in an avalanche. So just because you're in a ski area, it doesn't mean you can totally let down your guard. I think, especially as you complete this course, you'll have the tools to know what to look for. And when it's a high danger day, the more you're keeping track of the conditions and you just kind of paying attention to the obvious signs. I mean, if it is just dumping snow and you're at a ski area, there's still a reasonable chance that you could trigger, usually it's going to be a very small, isolated little avalanche, but storm or wind slab type problems, and also wet snow avalanche problems, like those things do happen in bounds. So, I'd urge you not to let down your guard fully. And I will often, if I'm skiing in an area when I know the backcountry avalanche hazard is high, I'd probably be at a minimum at least wearing my transceiver, if not carrying gear. And I'm usually not going to ski with a backpack unless I know I'm kind of going into side country terrain or out the gates. But just it's a little extra insurance that doesn't cost us anything, right? You've already got the gear. You might as well have the transceiver in your pocket and switched on in that worst case scenario if you were to get yourself buried.
Yeah, I think what it highlighted for me was that how different they manage their mountains in Europe than here in the US. And I caught on after about a day or two, but it was very different. So just knowing what that is, puts a sense of different perspective on where you're skiing and what conditions you're skiing under.
Mm-hmm. Yeah, Japan is similar. I think Japan's taken a very European centric approach to how they manage their ski areas, and that varies depending where you go, but often in Japan, same deal. As soon as you get off the groomer, you're essentially on your own in terms of avalanche risk. The US and Canada, we have a higher degree of more trust in the ski areas and the patrollers to keep those slopes safe, and they have a much higher degree of responsibility, both personally and legally for that. So definitely an important thing to know. Cool. So did you all get a chance to look through that little terrain exercise I sent out? Yes, no?
Yep.
Yes.
Cool. Let me pull that up and we'll do a quick review of that. Yeah. And Matt and Clark, we talked a little bit about kind of terrain classification last night. Hopefully you each had a chance to look at that link I sent, the Abby Savvy through Avalanche Canada. Gives a pretty good overview of it, but if you didn't, definitely take a look at that afterwards.
Chance to go through it. Thanks for sending it.
Okay, so the idea on this is to, first of all, just kind of looking at overall picture of terrain. How would you describe the entire view? Like, would it be simple, challenging, or complex? And maybe like some of these photos we can identify like certain parts of that terrain would be simple and adjacent parts might be challenging or complex. And then we can take that a step further and just kind of using like plain language, like how would you describe some of that terrain? So let's start with this first one here, photo A. This is from up in the Kootenay region up in BC. But what do you think? Simple, challenging, complex?
Combination of challenging and complex, probably.
Yeah, I'd agree. I think definitely some of that like high alpine terrain, kind of in the middle, that middle peak there. You know, it's hard to tell with just looking at the photo from this angle, like how steep that is. You can actually see the ski tracks kind of right down the middle. So that whole face is actually relatively low angle. And when we start talking the shape of the terrain, I would describe that as both planar and pretty well supported, you know. So planar, kind of the alternative to planar slopes would be like very undulating. So if you think of like a snow-covered glacier, you have a lot of these convexities and sort of shifting aspects and slope angle, right? But planar is like if you just laid a sheet of plywood down, right? So regardless of the angle, it's a nice consistent slope in terms of the angle aspect, all that. Supported, you know, if you think about a bunch of snow sitting on a slope, and if you get like towards the bottom of that slope and you get more of a convexity or the angle increases, or you have a slope that's kind of situated like right over a cliff line, there's nothing holding that snow in place. And this one's really hard to quantify, but once you've like made the decision to move into avalanche terrain, you still want to choose terrain that's going to lower your exposure. And so generally you're looking for those slopes that are more planar. They don't have a bunch of convexities. They have kind of a supported bottom. So when the angle kind of gradually decreases towards the bottom of the slope, you know, that snow below is sort of holding all the snow on that slope in place to some extent. How else would we describe some of this terrain? So right in the middle, that middle peak, you know, the upper bit, pretty planar, supported by this bench down here. Although, you know, past that flat bench in the terrain, it does drop off pretty steeply. What else? Like, how would we talk about like tree cover in this piece of terrain? Would you say dense trees, or is it more open slopes?
I would say open slopes, and the ridge off to the right, that looks hard to tell the convexities off this as it comes closer to you, but on the top it looks fairly smooth. So almost, would that be simple terrain, the ridge to the right, and
Yeah,
really sparse tree?
yeah, I think like there's a pretty, you know, like sort of agreed upon definitions of like what's simple, what's challenging. But yeah, when you have like something that's pretty consistent and you're looking at that slope and you're like, no matter where I ski in there, it's hard to either get into trouble, or when we talk about more challenging or complex terrain, it's often like we have to make these micro decisions, and the more challenging the terrain gets, the easier it is to ski into something that starts to take on a different character. So either the aspect shifts or the angle increases. So yeah, I think like that upper right, that specific component, I would rate as simple. They didn't prompt us in the questions, but you know, start thinking about how is this slope or the terrain in this photo, how is it exposed to weather? So wind, sun, like what do we think about, you know, across the horizon there in the upper parts of all those peaks, like pretty exposed to wind, or does it have some wind sheltering?
Pretty exposed.
Yeah.
Yeah, I'd say exposed.
Yeah, so definitely exposed above tree line terrain. And then you kind of, as you come lower in the photo, you're getting into that near tree line And then obviously if you continued skiing down, that turns into pretty dense woods, like nice BC Canadian storm skiing down there in the trees, but up above there, some above and near tree line terrain. Anything else to add on that one? Pretty much covers it from my perspective. All right, how about this one, photo B?
It almost feels, Eddie, I mean, it feels like, I mean, we have a lot of situations like that on Crystal on Northway where you're starting out a little bit planar in that regards, and then you're falling into a line of chutes, right?
Yeah. Yep.
And so you go from this two different conditions versus if you start out on a peak like this, you see exactly what you're getting from the start, right?
Mhm.
You look down and see that pitch. It seems that when people get even more into trouble in photo A, assuming that you've got this easy glide path and then running into these more complex situations as you continue to go down the slope.
Yeah, that's a good point. You know, so it changes, and that's where, as you're planning your tour, you know, if you're to look at a guidebook, they might try and apply that terrain classification on a broader scale. But as we're moving out and planning our tours, it's okay to be like, okay, we're going to be up in this one zone. It's mostly simple terrain. And then to get out of there, we're going to have to, as long as we recognize like, okay, now we're shifting into some more challenging terrain and we've got to reassess as we go. That's super valid. And yeah, common, I'd say a pretty recurring theme in the Crystal area for sure. And you were comparing that to this one, Clark, like saying that, you know, you kind of know what you're getting here. So in that way, it is a bit simpler.
Well, yeah, just it seems like there's a pretty even pitch on this one and you're seeing it from the start. So once you're, you know, it feels like you'd be preparing for this all the way down for the most part versus the other one could fool you in a lot of ways, right? Depends on cover and everything, but I don't know, I was thinking, do people get into more trouble on that first one? It seems they get a little bit more complacent within that.
I don't know, you know, I think you could speculate either way. I think with this photo, you know, I would rate this as complex terrain. There's a lot of like small changes in the terrain where you can get pockets. There's a lot of different probably avalanche types that you're going to run into, like the aspect, you know, as you kind of move across that bowl from right to left, that aspect changes. So probably more, the shaded slope is going to be more northerly. It shifts more towards the westerly. So the northerly slopes are going to hold colder snow, which is going to tend to create sort of one set of avalanche problems. And you move on to the more sun affected slopes, big steep features above, they're sort of constantly sloughing in, you know, and here you can kind of see these like sift cones or like slough deposits. It's coming off this upper face. And this stuff is going to, you know, later in the day, granted, see a lot of sun. So maybe you're having wet snow problems in there. And one thing to note is where these sift cones are. Can you all see my cursor?
Mm-hmm.
Yeah, so when you get those, it's similar to like wind affected snow. So if across this whole chunk of terrain, maybe you don't have any slabs developing, but where that snow is like constantly kind of running down, it's getting more packed in and consolidated. So you might have these little micro pockets where you have a stronger slab, and then you put some sun on that slope. And similar to what happened in Austria, like you have a slab and some weaker snow below it, and it's all good until suddenly you start warming that snow, and then you can see some avalanches. You know, no tree cover here, so a lot of kind of unsupported convexities above tree line terrain. So definitely like a pretty challenging place to get through. But to your point, Clark, like you're probably not going to find yourself in that terrain with any misconceptions of what you're getting into.
Yeah.
How about this one?
Seems pretty simple.
Totally. Yeah. Simple, like relatively low angle, just just enough angle where it's fun to ski. A lot of old growth trees around. It's sheltering that snow from the wind, sheltering that snow from the sun to some extent. So this is, when the storms are raging, especially around here, like this is the terrain we're looking for, where we can get out, ski some nice powder, keep our exposure minimized, and just have a nice day touring. All right, how about this one here?
Similar to A, it seems. Otherwise,
Yeah. Yeah, you kind of have, I think, a little trickier than A. So you could much more easily here, like you think you're kind of sticking to the more planar, consistent slope in the middle, but if you make a turn and sort of not realize you're getting off course, you're sort of changing aspect and getting into this terrain that rolls over steeper.
Mhm.
But yeah, similar to photo A. This is actually like Hannigan Pass area up near Baker and Shuckson. Really cool terrain. Hard to get to if you don't have snowmobile in the winter, but awesome skiing terrain if you can get into it.
Looks like that's got some gnarly terrain traps though.
Yes. Big terrain traps like here. Obviously you've got this breakover in the terrain, kind of cliffy / convex. And then if that were to all release, it's going to just pile up real deep in this little bench in the terrain, and then lots of trees to get pushed through. And, it's like a cheese grate if you take an avalanche ride through trees like that, cliffs, and this upper slope here, maybe the biggest difference between this one and photo A is you have this upper slope. It's definitely steep enough. Again, hard to tell from this photo just how steep, but very unsupported here.
Yeah.
Whereas photo A, like that upper slope stayed pretty supported no matter where you're at on it.
so when you're referring to terrain trap, are you meaning the condition of not getting out of there, being able to ski out of it because you're down in a bowl or something like that? What is that referring to?
No, terrain trap is anything that's going to increase the consequences should you be caught in an avalanche. So that's either like things like cliffs, trees, exposed rocks that are gonna just like batter you up if you're taking a ride on that moving snow, or things that are gonna like cause the snow to pile up much deeper. So anytime you have like a flat spot or a bench in the terrain, roads or cat tracks are common terrain traps for that reason, and also gullies. So there was definitely there's probably a number of accidents. There's a one fatality in Colorado, like it was a while ago, but like a pretty small slope, almost it's like a road cut kind of thing, coming out of the woods, and someone triggered an avalanche there, and it kind of landed in this gully feature. And so even though it wasn't a huge slope and not a lot of snow, it ended up being like a 6-foot deep burial. Because that snow, rather than spreading and fanning out over the terrain as it came to a stop, it just hits this stopping point and just piles on top of itself.
That's what happened in Campbell Basin a few years back.
All right, what do we think about this one?
Is that a cut right there in the snow? What is it?
In here?
Yeah.
That's a crown line. That was a slab that had released here. And you can't really see in this photo, but there's a big terrain trap feature kind of just below this. There's sort of this ridge in the foreground, but sort of a big gully feature that runs along that. So again, that's going to increase the burial, or the depth of the debris pile. You think? Probably not. Well, what would you guys rate it?
Is there a safe way? Ridge and
This whole face in the middle is, I think, 35 to even 45 degrees. So pretty steep all through here. I think you could argue, I would rate it challenging. You know, it's like you know where the avalanche terrain is, and it's, you know, easy enough to avoid it. Like you essentially would avoid that whole face if you were concerned about stability on that slope.
This one almost looks scarier to me because it feels so subtle.
Yeah.
You just want to ski across the line, right? Across the face of that thing.
Yep. And it's like a really cool ski run. I've skied it in the springtime when you get like a nice corn cycle. This is Red Mountain off of Snoqualmie Pass. But winter, most people don't go up there in the winter because this whole thing is avalanche terrain. So challenging. I think you can make the case for complex. Cool. It's the last
See
one.
that one's interesting because, you know, if you're looking at it from like a skier's aspect, you know, it doesn't look very complex to ski, right? But from an avalanche condition standpoint, you know, it seems like it'd be, you know what I mean? Like from a skiability standpoint,
Yeah.
it's pretty straightforward, but from an avalanche standpoint, like I could definitely see rating this one complex, especially you're looking at the, you know, the fracture there, like right in the middle of it.
Yeah, I think what my argument for rating it complex would be, you know, depending on the loading pattern. So this face does see quite a bit of wind when the storms come in. So depending which way the wind's blowing, that's going to maybe load it differently. And it would be hard to tell like exactly where the avalanche paths are, right? So under really unstable conditions, if the forecasters are saying like, yeah, we're expecting like very large avalanches, potentially that whole face could go, but there's kind of a lot of like kind of small avalanche paths that are really hard to determine from looking at this photo. So you can't really distinguish like where those are and maybe where there's like a low angle sneak through them. And so, yeah, that's kind of I think when I start thinking complex terrain, it's like a lot of overlapping and hard to distinguish the boundaries between like particular avalanche paths.
Yeah, this is a tricky one. This is one we'd ski by all the time without even thinking about it.
Yeah. So just, you know, the point of this exercise is to get you thinking about looking at the terrain, sort of giving it a bit of a rating for yourself. Like, is it simple, challenging, or complex? That ties back to like our terrain choices and the mindset that we pull into our planning phase. And then also starting to go a bit deeper in like, what is the consequence? Are there terrain traps? Do we have options to avoid the avalanche terrain if we're there and we realize it's, you know, it's unstable, or are we pretty committed to it? So not really any right or wrong answers with it. It's fairly subjective. Nice work there. So tonight, like I said, we're going to get into kind of looking at these conditions. So Matt and Clark, one thing I presented last night, and it's in those slides, but there's kind of this 3x3 matrix that I presented, and I'll kind of recap that because it comes into play here a little bit and what we'll be talking about. But definitely jump in if you've got questions, or if you need more explanation, just shout it out.
Okay. Yeah, I think it was pretty straightforward. I mean, different examples of thought process.
Yeah, and last night we kind of focused on more of the decision making, and so a lot of that we'll continue to like discuss and emphasize again and again when we're in the field. Before we get started on this, since you're jumping out early, Skip, weather and conditions for Thursday and Friday, it does look pretty rugged. And my thought at this point is we'll go out Thursday, see what we can get done, and if things are just, if it's just so nasty that we can't even, you know, just so uncomfortable that we can't even like accomplish the course objectives and learning, we can reschedule that second day. And it's a bit of a long shot, but so we have 2 groups here. We'd have to have kind of full buy-in from each group, but and I talked to Jeff today. He was unsure if he can make it happen tomorrow, but if everybody could get out tomorrow, that's an option we can discuss.
Mm.
But I know it being a midweek day, last minute, probably a long shot, but I personally, I have availability on, and I could get out tomorrow. So, for the Langer crew, maybe you all can discuss that and get in touch with Jeff. And then for the split board crew that'd be with me, we can come back to that before we wrap up tonight.
Sounds good.
All right, so like we talked about last night, we have sort of this idea of the avalanche triangle. And for Matt and Clark, a quick review there. Basically, to have an avalanche occur, regardless of humans are in the area, like we need these 3 things. We need to have unstable snow, we need to have a trigger, and then we need to have avalanche terrain. So you can have really unstable snow and you can come along and ski across it, like skiing into a meadow. Especially in a place like the Rockies or Colorado, we often are dealing with these like old snow, persistent weak layer problems. And so you're often like skinning in, and you just like, with good terrain choices, you know, you're not exposed to overhead hazard, you know, you're not on avalanche terrain, but you often get these like big whoops and like settlements of the snowpack. And what's happening there is that you're basically triggering an avalanche just on terrain that's low angle enough that it can't move. So, you know, we need all 3 of these components in order to actually see an avalanche. And the piece of that we really control and that has very little uncertainty is the terrain. So if we're not in avalanche terrain, we don't really need to worry about instability. We don't need to worry about the triggers. As soon as we're in avalanche terrain, then we're making, whether we know it or not, some assessment of stability and of our ability to trigger that instability.
And so, sorry, I might be a little bit behind. But
No, go ahead. What do you got?
Is terrain a condition of pitch and coverage, or what is the?
It's at its simplest, it's slope angle. So, and Matt and Clark, maybe you didn't have a chance to get through all the area online stuff yet, but who can tell us like what are some key things when it comes to slope angle? Like what slope angle range do we see the most avalanches in, and what's sort of like our minimum slope angle that tells us we're in avalanche terrain?
Is it mostly 39 degrees where you'll find a lot of avalanche, bad avalanches, and then below, I guess below 30, you're kind of in the safe area?
Yeah, generally below 30 degrees, you're not going to see an avalanche. There's a couple rare exceptions. And if we have conditions where that might even be a remote possibility, they're going to talk about that in the avalanche forecast. You know, basically 30 degrees or higher, but if there's connected terrain that's maybe 28 degrees above or below, you know, you can trigger that avalanche. It can release on the steeper part, sort of the sweet spot, and it can, depending on the slab properties, like pull some of that snow from lower angle terrain down. But yeah, generally under 30 degrees, we're in pretty safe terrain. The exact threshold, you know, we'll often see in the forecast, they're going to talk about avoid any terrain over 30 degrees, or they might say like common to out here in our snowpack, especially with like storm or wind slab problems, they're going to say avoid terrain over 35 degrees. And the real sweet spot for slab avalanches is between 35 and 45 degrees, which is the most fun to ski, unfortunately, but also the most dangerous from an avalanche hazard perspective. Once you get steeper than 45 degrees, we don't tend to see a lot of slab avalanches occur on like kind of steeper, what I would call like extreme terrain. We can still have avalanches, so loose snow avalanches. If you've watched any ski movie, you've probably seen them like riding the big spines in Alaska, and they're just they're kind of like outrunning or sort of angling off so that they're not getting taken out by their slough. But when you see slough, that's just a dry loose avalanche. And so those typically we're not worried about being buried by loose snow avalanches, but what they can do is knock us off our feet. And especially if we're above cliffs or other sorts of terrain traps, then those things can become problematic. So beyond 45 degrees, it tends to just kind of continually run off instead of that snow stacking up and forming denser slabs.
Yeah, I would guess that one that happened in the Alps was as close to 30 as possible. It was a pretty in bounds, intermediate, I believe, pitch on that. So it just happened. I think it happened to be the heat or the temperature going up and down with the snowpack. So, but majority is what you're saying, plus 35.
Yep. So that's the biggest thing in terrain. And then the things we were just talking about with those photos, it's like these other elements do come into play, but it's more like you're in avalanche terrain or you're not, based strictly off that slope angle. And then if you've made the decision through your planning and based on what that like local avalanche bulletin is telling you, that slope at that elevation and that aspect doesn't have like a forecasted avalanche problem, you can go in there, but then you still want to choose terrain that has some of those other characteristics. It just makes it a little bit safer to add a bit more margin in. So like I said, as we're moving through the backcountry, we're kind of always making some decision here, and the way that we're managing our risk exposure is either due to our terrain choice, like we're avoiding avalanche terrain and we're in it, or we're making that assessment on the conditions. And sometimes those things start to blend. You're using either or. So, as you get through the field days on this course, and then just like whenever you're out, check in every now and then and be like, just kind of ask yourself that question, like, are we managing the risk by terrain, or are we managing the risk by this, like we're assuming that this slope is stable, right? And it's always going to be a much easier decision to make when you're using terrain. But understanding the conditions and understanding the weather that leads to those conditions and how those things change is how we can avoid sort of the unforeseen. So this is that little 3x3 that we talked about last night. And the idea here for Matt and Clark is the columns are going to be basically these elements of our avalanche triangle here. So we have our conditions, we have terrain, and then we have our human element or decision making. And we want to kind of color code those as we go. So, and we have to have at any given time, at least 2 of those boxes need to be green lighted. So, like lower moderate avalanche hazard, on the slope we're on. So if the forecast is saying like, hey, there's considerable avalanche hazard, but it's on above tree line terrain on north and east aspects. Well, if we're below tree line, and then we don't have that avalanche problem forecasted there, then that we can still have a green light, even though maybe the forecast is moderate and considerable. So, where we plan to go, when I think green lighted terrain, green light for conditions is just stable weather, non-existent avalanche hazard on those slopes. And then terrain, I think we can just like simplify this one a lot. Simple terrain is going to be green lighted. Challenging terrain gets a yellow or orange light, and then like complex or extreme terrain is always going to be red lighted. And that doesn't mean you can't go there. It just means you have to have like very solid green lights in these other elements. And then, our human element is all these things like, do we know, are we with partners that we know well? We know what everyone's ability is. Everyone has good fitness, good ability to move through the terrain. We all agree on like our risk tolerance. So as you get maybe more challenging group dynamics, that could give you a yellow light or a red light there. And so as we move through a tour, we have all our planning that we do before we leave the house. That's going to be the pre-trip planning, this first row on the top. And then the middle is just as we move, as we're sort of approaching the objective. So that starts on the drive. We're looking at the mountains. We're looking at the actual weather, making sure that everything we planned to see and that was forecasted is actually happening. We're starting to look at the terrain, like as we get a view from a distance, like, is it what we thought? Or maybe there's more hazards there that we couldn't see from looking at maps or guidebooks, like more cliffs or more terrain traps, or on a glacier, like are the crevasses starting to open up or hidden with like fresh wind slabs? That might change our score for the terrain. And the human element, this just kind of stays consistent as we move through. And if we still have those 2 green boxes, we continue on with our plan. And then we sort of have our last chance check-in. We've toured up, had a good route plan, and we toured up, minimizing our exposure. And then we're going to drop into some avalanche terrain. And in this example, our plan was to go ski some challenging terrain. And if we get up there and we realize, there's actually more snow than we expected, or there's a lot of wind effect, or we're seeing signs of avalanches, suddenly our conditions get a yellow light. And that just means like we have to take our terrain down to a green light. Makes sense?
If you're seeing signs of avalanches, is that always a bad thing, or does that sometimes indicate that, well, that like hillside has already released and it's sort of done its damage? And so
that's where it gets tricky, because then we need to like take all these other pieces in and say like, okay, where we're seeing, let's say we show up and we see a crown line, like in that one photo of Red Mountain. We're going in and we see that crown line. Well, it's like we have to try to figure out like how recent was that, what caused it, and are we going to terrain that matches that terrain and it's going to have those same elements at play. So same snowpack, same exposure to weather. If we're just going to ski some low angle trees that's near that terrain, it's maybe not so relevant. Make sense?
Yep.
Another way to kind of look at this, again, a little bit of review from last night, is we make a plan, and then as we're in the field, we're observing what's actually going on, and we want to compare what we're observing to our plan. And if things start to diverge, then we need to adjust and choose simpler or safer terrain. When it comes to conditions, where we tend to see accidents is when conditions are changing faster or slower than we expect. And that's why it becomes so important to use these checklists and sort of this framework to continue making these observations throughout the day to make sure that like what we expected and planned to see still applies. Revisiting this, I'll kind of jump through this. Clark, Matt, feel free to reach out with questions on this later, but sort of looking at our known unknown quadrants and some examples of like what goes into those things. So, when we're making our observations, like our known knowns, like those things might change, right? Like that's all based on a forecast, like forecasted weather, our forecast or our perception of like our group abilities. But we might get out there and realize that those things aren't what we thought. And then, some of the unknowns are these things that like we have some uncertainty in when we're making our plan, and we know we don't have those answers. So we want to go out and maybe have some targeted observations that we want to make to fill in those knowledge gaps. And then sort of the unknown unknowns, these are the things that are like not even on our radar. An unknown unknown would be that avalanche in Austria. It's like no one skiing there was thinking they were exposed to avalanche hazards, right? So
Yeah.
those are probably the most insidious things that they're going to catch people by surprise. But
Mhm.
so in terms of tracking conditions, like we have to know a little bit about the snowpack and why we get weak layers and why we get avalanche problems, right? So the more we keep track of what's going on with the snowpack throughout the season, though, just the more informed we are and the better we can track those changes. So, I'd encourage you all to just make it a habit, at least a couple of times a week. Ideally, really every morning or evening. NWAC publishes their avalanche bulletin each night at 6 p.m. for the following day. So go on at night before you go to bed and just kind of read through like what's going on, so that when you get to the day where you're going to go out in the mountains, you've already got a good understanding of like what's been happening, right? When we start looking at the snowpack, there's kind of two elements we've got to understand. So snow falls from the sky, lands on the ground or the existing snowpack, and starts to just stack up over time. So there are factors that impact the properties of that snow while it's falling. So like the temperature of the storm, we can have like really cold, dry snow that's like the great powder that we all love to ski, or we can have that wet, heavy snow, which is more often than not what we're skiing out here, right? But so that's going to be swayed by, air temperature and wind direction, all these things happening like while that snow is falling. And then as that snow sits on the ground, snow grains are going to change over time. And either of those two factors can result in instabilities or avalanche problems. When we start looking at layers in the snow, at the simplest level, what we're concerned with is strong snow over weak snow. So while we're having, let's say we're like the storm that's coming in, right? This weekend, it's going to be, there's a lot of precipitation coming in. We're going to have, if we're above that rain snow line, potentially a whole lot of new snow. And then lower down as we get closer to that rain snow line, we're going to have this weather happening where maybe it comes in and it starts as rain and the temps start to cool off and it gets colder as the storm progresses. So how would you describe that snow if you're just thinking about the new snow that's coming with that storm? Under that sort of temperature paradigm, are we going to have strong snow underneath weaker snow, or vice versa? So starting out warm, moving towards colder temperatures during the storm.
You'd have strong over a week. That would, you would create an ice layer in there, wouldn't you?
Yeah, potentially. So maybe it starts with an ice layer, which is like the strongest we can get. And then as that snow comes in colder and colder, it gets, becomes more of that low density, fluffy powder snow. So that's weak snow.
Yep.
We would have weak over strong, which is good. That's what we call like a right side up when the storm comes in.
Eddie, would you generally say that warmer, wetter snow you would consider that a stronger layer?
Yeah, for sure.
Okay.
And it gets a little confusing here because we talk about the particular layers being strong or weak. That we need to separate that from the structure of the snow. So we could have that strong over weak, but maybe there's still a weak layer underneath. See what I'm saying? Like, if we flip that storm example, and let's say the storm starts cold and then shifts to warmer. So we start with like really cold, light, weak snow that's falling. And then the storm warms up, we get that more dense, more moist snow. Then we have strong over weak. So we have strong snow on the surface, but we have that strong over weak structure, and that's where we start getting problems.
Did we get some more? I mean, I haven't been here obviously for a while, but it was a cold spell, right, in December with some good snow. And did it warm up, creating this kind of ice layer, or has it been cold enough to maintain?
It depends where you're at. Like really it's elevation driven.
Mhm.
It has, yeah, it's
Crystal is an example between that kind of 4 to 6,500 feet, 7,000 feet. Did that maintain below freezing enough to not create that ice layer?
I'm not sure. I haven't been down to Crystal recently. I know around Snoqualmie, we have like a very strong rain crust that's buried like now 1 or 2 feet deep. And then it's stayed mostly cold above that. The last few days, like we're starting to see some sun breaking through the clouds. So that's going to be starts to be more aspect driven. So some of the slopes that are more, on the southern half of the compass, and depending like what time of day the clouds broke enough to get some sun effect, like we're seeing that surface snow start to become a bit more dense. But if you get on like a cold north facing shady slope, that snow has stayed pretty cold. So, the main changes that are going to happen to snow are we have wind, we have sun or rain, and then just like temperature. So what sort of effect do you all think wind is going to have on the snow? Is it going to, in general, is it going to make it stronger or weaker? Just talking about that surface snow, not trying to think about, instability or weakness of the snowpack structure, but just that surface snow. What does wind tend to do to it? What does it feel like to be skiing over wind affected snow?
I think it would make it stronger, right? It's compacting it.
Yeah, it's compacting it, it's compressing it. It also moves it. So what happens with wind, especially if you have relatively fresh snow that fell with that kind of nice cold, low density characteristic, suddenly the wind picks up and the wind's going to move snow from one side. So the windward side of the mountain that's facing the wind, that snow is going to get sort of scoured off and moved and then redeposited on the leeward side. And so when that snow gets redeposited on the ground, it's been sort of bounced around in the air. The grains are going to be more rounded and packable. And so when they fall back on the other side of the slope, it's forming more of a dense slab. We can also have like, if wind is sort of scouring, or wind can be sort of pressing the snow. So we can have sort of wind pressed snow, and we can have wind deposited snow, but regardless, like the wind is going to make the snow surface firmer and stronger.
Like that top photo, right? Those wind drifts right there.
Yeah, and so that texture in the snow that you can see above in here. So you see how there's like these sharp ridges to these little, it's like snow, like wind sculpted snow here. Even here. So those, when you see that, that's called sastrugi. Or you can just call it like wind ripples. But what that tells us is that can help indicate like which way the wind was moving. So the sharp edges, the shadowed ridges here, those are going to be pointing into the direction the wind blew from. So in this photo, the wind was blowing right to left. And what's critical to know there is like this rippled snow, that's not where you're going to find the wind slab problems. Where you're going to find the wind slab is in the smoother, pillowy looking snow, because that's where that snow got redeposited into a denser slab. But often this stuff, that means like the wind was kind of moving the snow off that slope. So you can use that as clues, and you'll often be able to see, and it's not the easiest to see in this photo, but over in here, it's much smoother and has this like pillowy look to it. So that's where, if we're concerned with wind slabs, I'd be avoiding this snow. And even though the skiing is going to be worse in here, that's going to be safer from a stability standpoint. How about sun and rain? What does that do to our snow?
I think it weakens, the warming of the sun weakens the snow. It makes those like wet, loose avalanches, I think.
Yeah, and it actually, it's going to kind of go through a whole cycle here where, again, if we imagine just like fresh snow, fell nice and cold, hasn't been affected by the weather. It's just nice, fluffy powder skiing. Once we start putting some sun or some rain on that snow, at first it's going to just like make that snow more dense. So it's actually going to create more of a slab and actually strengthen that snow. And then if we get too much moisture, then that snow again becomes weak and you end up with wet snow problems. With any of these things, the more, the more drastic the change in the weather and the more rapidly it happens, the more unstable that snow is going to be. So, fresh snow is more susceptible to all these changes than like well consolidated old snow. So if you think about our snowpack as we get into spring, like think of like how would you describe like this, a spring snowpack?
Heavy.
Yeah, heavy, maybe even firm, right? Like how does it feel to ski over it?
Super
Sticky.
dense below and maybe loose on top,
Yeah.
loosened by the temperature.
Yeah, and the more it kind of goes through those cycles, eventually we get ultimately into that corn cycle where it's freezing overnight, softening up during the heat of the day. But that kind of snow, it's much less susceptible to all these changes. But the fresher the snow, the more easily it's going to be impacted and become probably unstable when you start adding these weather elements to it.
Hey, Eddie, so you're talking about the layers of snow here, weak, strong, middle of the road. But how do those play into like the interfacing of those layers, which you're kind of touching on a bit, but say that, freezing rain event that we had, and then it freezes up. Is that interface something that throughout the entire season is going to be an issue that people are going to be looking at, or eventually does it compact and bond enough that it's something that's not of concern?
It really depends. And that's where we got to rely on the experts. So we're going to rely on what like the forecasters at NWAC are telling us, because like interpreting those changes and then pulling all this evidence together, like maybe going out and doing like certain mechanical tests, like snowpack test or making observations, looking at the weather telemetry, like all those things that becomes like PhD level snow science, which is way beyond all of us. So we're really relying on the forecasters to interpret that and tell us like if it's an issue or not. More times than not, in a maritime climate like we have here, those crusts, like we get a rain on snow event and it just locks everything in place, and then the new snow is going to bond pretty well to those layers. But not always the case. And again, that's where we got to rely on NWAC to tell us what to look out for.
Is there a correlation to how fast that temperature drops? That because it seems like the slower it drops, the thicker that crust can maintain to develop, versus if you dropped fast, the layer might be thinner, right? Just because it's not getting down into the next layers. Do you see any correlation to the speed of that temperature coming down?
Totally. But it's pretty complicated. Like there's so many variables in there. It's like the time period over which like that temperature drop happens, like what's the magnitude of that temperature drop, what was the characteristics of the snowpack before that happened. Like there's so many variables there, but for sure that has an impact. And yeah, it's going to change the thickness or the strength of that crust that develops. And maybe the key takeaway there for us is as we go up in elevation, a lot of times when we have those events where we get some rain and then it freezes, like the character of that crust is going to change as we go up in elevation, because that all those factors are different as we go higher. Like it's colder. Maybe there wasn't as much rain falling or no rain falling at certain elevations. So all those things come into play, and it changes throughout the terrain. Just skipping through these. These are like stock AIARE slides, but I think we've been talking about it enough. We kind of have all been out. We know, what the snow feels like. We can imagine that stuff, right? So the important thing is to recognize that like these elements have an impact on the snowpack, and they're going to have an impact on the avalanche problems. Now, in terms of the changes that actually happen to the snow grains that are on the ground, there's basically two ways that it can go. So snow grains that are already on the ground, they're going to go through either a rounding process where they gain strength, or they're going to go through a fastening process where they become weaker. Rounding is what we nearly always see happening in our snowpack here. So what favors rounding of those snow grains is relatively warm air temperatures and a deep snowpack. So you can think of the snowpack depth almost like a jacket, and the amount of like loft that your down jacket has, right? Like the thicker it is, the warmer you are, the happier you are. Is anybody like, are any of you happier when it's really cold and you're out there in like a really thin fleece? Or would you be happier in just like a big, thick down jacket? Probably the down jacket, right? So snow grains, like the little grains, are kind of like humans. We don't really like change, and we definitely don't like a lot of change quickly. And the warmer we are, we're just going to feel stronger. If you're out there shivering on a cold day without enough layers on, how do you feel? Like you're probably going to feel eventually like kind of weak and like you're just not happy. So it's similar for the snow grains. When you have a relatively shallow snowpack and cold air temperatures, we're going to see those snow grains actually start to change, and it's called faceting because the grains start to develop these sort of sharp angular faces, and sometimes those things are they just continue to build and sort of grow, and this whole process, again, it's like getting way into physics and snow science, but it essentially has to do with water vapor moving through the snowpack. And so when you have really cold air temperatures and a shallow depth to the snowpack, that water vapor just moves a lot quicker to escape, versus our snowpack, like we just kind of like hold that stuff in there, and that makes our snow grains generally much stronger because they're all rounded. If you go to the Rockies, you're going to see much more of this faceting process happen.
Yeah. So it's just wicking out the moisture a lot faster in that. So it's not allowing it to bond.
Yeah, pretty much. And so you kind of imagine like that moisture, water vapor, like kind of rapidly evaporating off of the little snow grain, but as it moves, it just like kind of starts to refreeze as it goes on itself. And so it grows and you get these faceted grains. Whereas when the water vapor is sort of moving kind of slow and sort of lazily, it just kind of like bounces around in there and starts to just like refill in and round and start to like sinter and bond all those grains.
This is sugar snow. This is like champagne.
Yes, this is the stuff, like, it's unfortunate, like no matter how hard we go out and look for it, we're not going to be able to find these grains anywhere near crystal.
Right.
But when you do see it, I mean, it's really obvious. And if you were to scoop some with your hand, you can't form a snowball with it. It's very loose, and if you kind of bounce your hand up and down, the snow grains are going to bounce, and it is exactly like if you were to take a handful of, either sugar or like sea salt, table salt, any of those things, like it just has this bouncy, airy feel to it. And so this is like our weakest snow that we can have. It's basically like a bunch of ball bearings that's supposed to be holding up the snowpack over it. And this is where you get persistent slab avalanche problems, which we're fortunate enough that we don't have to deal with that very often in Washington. So here's some pictures of, well-developed, large, faceted grains. And there's subcategories of this, like what we're seeing here would be classified as depth hoar. So this is the kind of snow that like sits at the very bottom of the snowpack and just continues to rot away and become weaker and weaker. The one that we do see fairly often out here would be surface hoar. And so this is when you've got usually some like fresher snow on the surface, and you get a nice, relatively cold night with clear skies and just a gentle breeze. And again, it's the same process of moisture evaporating from the snowpack. And then as soon as it like starts to leave that snow grain, it refreezes when that cold breeze hits it. And you get these like, sometimes like really large, like feathery crystals on the surface. So these are really weak. It's really fun to ski through this if it's on the surface. It becomes a problem if it then gets capped with new snow, and that new snow starts to form a slab. So then you have basically a whole bunch of dominoes holding up this slab of stronger snow over the top of it. We see it, every now and then we do see this develop in our zones where we go, but it tends to not survive very long. We'll either get some wind or moisture or sun or anything, like it's pretty fragile, so it's pretty easily destroyed. If you were to go further north and skiing around like a lot of areas in British Columbia, this is a common problem, and it will develop and then it will also get buried, just given the snow climate and the terrain up there. So this is often the lurking, persistent slab problem that you'll see in parts of Canada.
So is this a direct result of just temperatures jumping up and down around freezing on the western mountains versus Colorado, where you can get below zero and you kind of stay there for the winter?
Like surface hoar really doesn't have much to do with temperature fluctuations. It really has to do with like a clear night when you don't have any cloud cover. And so the cloud cover has a big impact on the way that radiation is escaping and being reflected back into the snowpack. So when you have a clear sky night and it's, it doesn't have to be super cold, but relatively cold, a gentle breeze, and especially near creeks where you have a moisture source, you'll see this develop. And where it gets people, where it really catches people by surprise, like especially in areas in British Columbia, is like you're skiing in the trees and then you come across like a clear cut or a glade. So like in the trees, you're not gonna have that problem because the trees are gonna sort of inhibit that radiation escaping the snowpack. So you don't have in the trees, but you ski along, and then as soon as you hit a clearing in the trees, you could have had this. And if it's, again, it's something that should be in the avalanche forecast. But if that is something that's talked about, you've got to be really weary of those like sudden clearings in trees and glades or logging cuts, because that's where these things will be lurking.
Eddie, these last two slides you called persistent grains. It might be a stupid question, but what's persistent about them? Is it that they remain intact over time and get buried and remain intact within the snowpack?
Yeah, once these types of grains are buried somewhere in the snowpack, they're very slow to heal. Like they can over time like switch and go through that rounding process, but it tends to take a long time, maybe the whole season. So You know, in Colorado, oftentimes we have these persistent grains near the bottom of the snowpack, and they don't go anywhere until we get into a full spring cycle. Like you get sort of that melt freeze cycle happening every day and night, and that it goes on long enough where it actually gets down and gets to these grains. So
there's not a say consistent rounding process happening.
Right. Right. And because once they've developed, the larger these grains become, the harder it is for them to round out versus like some of the smaller faceted grains, like near surface facets. They're going to be small grains. They're going to still have that sort of bouncy feel to them, but those might round out quicker than things like this.
Got it. Thanks for that.
You know, so with all those kind of snowpack, mountain snowpack qualities in mind, like that's where we get into these different types of avalanche problems. Right. And so this is where we're taking this information from the avalanche bulletin from NWAC. They're going to tell us what problems we need to look out for. And the reason that we use these different problem types is it helps us know what to look for to identify the problem. And we also have some clues as to how to manage those problems. And we can break them down, like simplify it further into new snow problems, old snow problems, and wet snow problems. And in the field book you're all going to get, there's a kind of a version of this chart, and it breaks it down by the problem types. And then it gives us like kind of the critical observations to make to identify that. It's going to give us like maybe some tests that we can do or observations we can make to assess that a bit further. And then it kind of gives us some, you know, in this chart, it's labeled important considerations. I think in the new book, it's like travel considerations or kind of like how we then manage that problem. And this is, I think, one of the most useful things of this whole course and having a field book with you is that this is the cheat sheet that gives us the information we need, combined with the avalanche forecast to avoid the avalanche problems in the terrain and have successful ski tours. So real quick, this should be a review from all the AIARE Online stuff, but we have loose snow avalanches and we have slab avalanches. So loose snow, as I talked about, it's the lowest risk to us as skiers. Doesn't mean it can't be dangerous if there's terrain traps, especially with like loose wet. They can be enough that it just kind of pushes you off balance or causes you to fall, and you know, it might lead to a blown knee or some sort of injury. But generally a loose snow avalanche isn't going to bury somebody. And we'll see these things happening, like they're going to start from the point, and as they move down slope, they're going to fan out and just entrain more snow. And they can still be, you know, pretty big, especially loose wet with our snowpack. But they're also going to be slow moving, and they're pretty avoidable. Dry loose is like our typical slough type thing. So, you know, where this skier is just sending it through the rowdy town here.
Is that Clark? Looks like Clark.
That's incredible.
That's Clark.
You know what the scariest thing about that is you have no idea where you're gonna land because that snow is gonna be below you. That is incredible.
Yeah, that's the next level. But a nice illustration of like if you're skiing along and maybe you don't mean to send it over that cliff line, you know, if you trigger a dry loose or slough, that might push you over it or push you somewhere you don't want to go. So that's where the main problems with these is looking off of the train traps that it can cause you to ski into. So slab avalanches, these are more of what we're concerned about when we start talking about people getting buried and injured in avalanches. So
How thick that
Um,
thing is.
this is where we have like, some layer of strong snow that bonds well and becomes a cohesive unit, but it's stacked over some weaker layer. And that's where we get the big avalanches. So the big differentiator between a slab avalanche and a loose snow avalanche is slab avalanches are going to have this crown line across the top rather than that point release and fan structure. And then you have sort of the flanks, which are kind of the side boundaries of where the avalanche ran.
Mhm.
You've got the bed surface that it runs on. Stock wall, that's kind of where, basically that's like the bottom boundary of the slab that released. Not too relevant for us. And then the debris or deposit of the avalanche.
That slope doesn't look that steep, does it?
It
Maybe it's
does.
just-
A lot of times it can be pretty deceiving, especially when you're looking from a distance. And that's where good terrain, the ability to read terrain in the field and also have a good tour plan where you have a good understanding of the terrain you're going to move through and you're trying to avoid those little pockets of avalanche terrain. So storm slabs, where do you think if there's a storm slab problem forecasted, where would we expect to find that? When we talk about like locations in the mountains, the main things that I want to know are elevation, so above tree line, below tree line, or near tree line, and then aspect. So with those parameters, like if a storm slab problem is out there, do you think it's going to be specific to certain aspects?
Well, would it be the opposite? Did this storm come up from behind this ridge?
We don't know. In general, so with storm slab, the context of it is like you have new snow falling, relatively low winds, most likely. So that snow is just falling and kind of blanketing the terrain evenly. So storm slabs, we kind of expect to see them anywhere and everywhere. So any
Not
aspect,
aspect dependent.
any elevation, right? And these, like the way to avoid these is going to be primarily by slope angle. So if it's a storm slab problem, if you're on a slope steep enough, it doesn't matter what way that slope is facing or where it is in the terrain. Now, wind slab, where do we expect to find those? Do you expect to find those as much below tree line as you would above tree line?
More above tree line.
Yeah, like you got to have terrain that's exposed to the wind. So below tree line terrain, generally it's down low in the mountains. So it's sheltered by the terrain. It's also sheltered by the trees. So you don't have as much effect of the wind. But above tree line and also near tree line, where you start to get into maybe sub ridges and sort of this terrain that, like, yeah, there might still be trees, but it's starting to open up and it's more exposed to the wind. It's gonna be aspect driven. Interestingly, like NWAC, if they're forecasting a wind slab avalanche, they, as a like kind of protocol, they don't put that to specific aspects. And that's because of our terrain in the Cascades. Like it's so steep and rugged that the wind does lots of weird things as it moves through the mountains. Like it swirls, the wind is directed by the terrain. So it's hard to forecast the particular aspects that a wind slab will be on out here. So generally you're going to see this like near and above tree line, all aspects. And so then it's on us to, as we move through the terrain, to look for visual clues and tactile clues. Like how does the snow feel? Do we see these like visual clues that it's wind deposited, right? Like, so that rippling or sastrugi, and then the pillowy, smoother snow where it was redeposited, We're also going to feel as we tour through that terrain, it's a lot firmer than, if we get down below the ridge, kind of closer into the trees where it's less wind affected, we're going to have softer, weaker snow on the surface. Wet slabs, how would like aspect and elevation affect these? Are we going to see many of these on north facing aspects that don't see much sun?
The aspects that see, majority of the sun, I think.
It's kind of a trick question, really, because the wet slab problem might be driven by a rain on snow weather event, in which case the aspect isn't going to make much difference, right? The rain's going to fall anywhere. But if it's just a temperature and like solar exposure driven problem, then that's going to be more aspect dependent. And they could be elevation dependent too. So lower elevations just going to have warmer air. So we might have a different wet slab problem down low than we would like way up in alpine terrain. Persistent slab. These are, again, we need to have that persistent grain type or weak layer that's buried somewhere in the old snow. And these tend to persist. That's why they're called persistent. So once they form, they tend to not go away. The other kind of big thing to know about these is when they do release as avalanches, that avalanche is going to tend to propagate like across terrain features. This is where we see these like really large, like really wide avalanches, like an entire alpine bowl rips out, right? These things will jump through and over ridges, and you can remotely trigger them. You can trigger them from across the valley. Like they're pretty scary. And then a deep persistent slab avalanche. This is where that weak layer then becomes so deep that it's really hard for the weight of a skier to trigger it. But that weak layer is still there. It's still lurking. So it becomes very unpredictable, and it becomes like really low likelihood, but really high consequence. Where we do see some of this, like was it 2 years ago, I think we had this problem in Washington, and we had a rain crust, and then we had really cold temps and a little bit of fresh snow. So we had fresh snow on that crust that got really cold, and that snow started to facet out. So then we had these like faceted grains on the crust, and then over time we had like several meters, like 10, 15 feet of new snow on top of that. So that weak layer was down there. It was pretty dormant, but it was on the forecast. And then like a month later, there was a few like historic sized avalanches that released. One of them in the Alpental Valley off of the Chair Peak Basin. You can go back and look at those things on NWAC. I can try and dig that up and send a link to it. Kind of cool to see. But again, this thing was in the NWAC bulletin. They were like really emphasizing it, like, hey, I know everything, like on the surface, everything seems good. Like you got relatively stable surface snow. It was good powder skiing, but we still had this like scary monster lurking in the snowpack. And so the only way to deal with deep persistent or persistent slab avalanches is like you just avoid any terrain where they might be.
So that avalanche control that they did at Crystal a couple of years ago that wiped out all the way down into the lower bowls, did that just force that deep persistent slab off of Queen that went down into
Campbell Basin you're talking about?
Yeah, off the backside of Campbell Basin. It came down off of it went through the bowl off of Queen. And they blew it, but they didn't expect such a deep cut. And so it knocked it probably had about a 8 or 6 to 8 foot cornice on it. That ground.
Clark, I believe that was a wet slab. So, some of these avalanche problems, we classify into these 9 categories to sort of simplify and just give us some parameters in terms of like what to look for and avoid. But if you get a little bit deeper, I mean, there's like 30 or 40, actual like different types of classifications there. So I think that one was commonly referred to as more of a wet slab, but I believe it might have been one of those crust facet layers that was buried deep down there. So like you have that sort of deep persistent problem, but it was more of a wet slab on top of it. So you have like maybe multiple problem types going on there.
Yeah, I don't think I caught them off guard. Like they didn't expect that deep. They expected a couple feet, I think, and it took off that whole ridge.
Yeah. There's a few cases like that where ski patrollers were out. They threw an explosive on the slope, or maybe used like a larger 20-pound bag of ANFO, and it was like, they were trying to just get this sort of wet snow to go, and it went deeper. So those things do happen. Glide avalanches are pretty common out around here for us, especially in the Snoqualmie area. This is where you have kind of water percolating and running below the very surface of the snow. And they're going to happen in places where you have like steep rock slabs as the underlying terrain, and you get water moving through there. And what you often have first is a glide crack opens up. So, you can kind of see this up here and imagine that this was still filled in with snow. So what's happening is like the whole snowpack is starting to shift and pull down. And you see this almost like a mini crevasse open up. And once you see that, like you just want to avoid that terrain altogether, because once the crack opens up, it's super unpredictable. Like they throw bombs at those things all the time, and they're just really stubborn, and it will just kind of spontaneously let go when it wants to.
I think this is the one that happened in Austria. This looks like it just because there was just a big open swath of rock after it left.
Could have been, yeah.
Bond, and all of a sudden it felt like it seemed like it got to a point where there was just too much weight or temperature change, and all of a sudden let go.
Yeah, and it might have been, I mean, I think that was just more like a persistent problem. But I don't have all the details on it. These tend to happen, in pretty known areas. So there's kind of like frequent flyers, you could say, with glide avalanches. It's like, where there's a steep rock slab with some sort of convexity, and every year you tend to get a glide avalanche that happens there. So we just avoid those.
Yeah.
Final one here is cornice. So a couple of things to note about cornices. When they do break off, they tend to break off much further back than anyone expects. So, I mean, this is a monster cornice, like kind of like a glide. It's like a little unpredictable, especially as they get that big. But you just want to give these things a lot of space, stay well back from them. Plenty of people have been killed in the mountains where they were standing on a cornice that gave way. Just that cornice itself falling down slope can definitely do some damage. I mean, that's a big, usually mostly icy mass. If there's unstable snow below it, it can then trigger another avalanche below it. So cornices can sort of be compounded by what's below them. I want to show you guys a quick video that will maybe help bring a little bit of this together. Before we go on that, does anyone have any questions on particular avalanche problem types? It's kind of a lot, like a little bit of a fire hose at you all with that stuff, but the idea is to just kind of start to wrap your head around there's different types of avalanche problems and we deal with them differently. And then we can always come back to that cheat sheet in the book with the specifics of that.
Yeah, that cheat sheet seemed to have a pretty good, like, different ways of test, like just real sniff tests.
Yeah.
Like packing your boot in, see how deep that goes, whatever the case may be. Those are good.
Yep. And out here in Washington, I mean, I'm very rarely, if ever, digging snow pits to do tests on the snow. It's a different story if I'm back in Colorado or if I'm in other snowpacks where you're dealing with old snow problems. But if you have a surface snow avalanche problem, which is most of what we deal with out here, so storm slab, wind slab, wet snow, digging down doesn't really give us much information. Like all the information we need can be seen and felt on the surface, maybe like a quick little test where you're like sticking your hand in the snow and seeing how it feels and how it's acting. But we save those like snow pits for the persistent problems. But again, yeah, that cheat sheet is super awesome resource for that.
Yeah, those are probably the scariest. I mean, I think that we sneak up on those cornices pretty quickly, right? Even going out onto the out at Crystal, that's a pretty size out there.
Yep.
Thanks.
So when we start talking about slab avalanches, even if it's so like a storm or a wind slab, you know, we don't need to have a persistent slab problem to start having to worry about this idea of propagation. So we've got a slab, so strong snow over weak snow, and that weak snow may or may not be a weak layer. But once we have that structure, there's kind of these two components that are required for an avalanche. So you have to have that structure, and you've got to be able to initiate a failure in the weak layer. So as you ski across it, does your weight as a skier, or potentially the stress or weight of like new snow or anything, like any trigger, can you initiate a fracture there? And then does that fracture have the ability to then propagate or cross the slope? And you've got to have both of those things in order to have an avalanche. So this is a quick little, about a 5-minute video that does a pretty good job of explaining that.
Shown in red in the weak layer, shown in white under his board. With the slope release a slab avalanche? Fracture mechanics tells us it depends on the length of the crack. To explain why some cracks propagate and others don't, this video introduces basic concepts from fracture mechanics and applies it to human-triggered slab avalanches and to snowpack tests. This photo shows a crack that started in a weak layer underneath a ski. The crack is subcritical. Remember that word, because it did not spread far enough along the weak layer to propagate. In this case, the fractures that angled down through the slab likely stopped the crack in the weak layer from spreading. The concept of a critical crack length is the basic concept from fracture mechanics that we will apply to human triggering and to snowpack tests. Cracks that don't spread beyond the localized dynamic stress underneath the skier, snowmobiler, or whatever are subcritical. If a crack becomes long enough, there is enough elastic and gravitational energy near the tip of the crack to overcome the resistance to crack propagation.
This is sometimes called self-propagation.
Because as the crack advances, say 10 centimeters,
I just want to pause it for a moment too. And he's throwing out some, you know, pretty like esoteric vocabulary here. Don't worry too much about all these terms like critical cracks, subcritical cracks. What I want to get across is just sort of the process and illustrate what we mean when we talk about propagation. And if you're curious about this stuff, it's really fun to get into the weeds and learn about all these things and release mechanics. But again, try to pay attention more to just like what this looks like and what's happening when we actually see that propagation.
more than enough energy is released to drive the crack another 10 centimeters. On a slope that is steep enough, a propagating crack in a weak layer will lead to crown, flank, and stalkwall fractures and release a slab avalanche. Let's look at what goes on under a localized dynamic load, such as a skier or snowmobiler. On this slope, there is a prominent, apparently continuous weak layer of surface ore between the rows of black dots. The skier tries to trigger the slab, but surprisingly, the slab does not release. At the same time as the attempt to trigger the slab, a second high-speed camera was recording. Watch which dots move in the upper row. Let's watch that again. Although the camera only had low resolution, we can see that the crack propagated only to here. The length of the crack when it stopped was subcritical. It did not become long enough to self-propagate. That is, it did not continue to propagate beyond the triggering energy of the skier. Now let's switch from triggering a slab avalanche to snowpack tests. In a propagation saw test, the result that is analogous to a subcritical crack is a crack that does not propagate to the end of the column from a short saw cut. Here, Corochet points to where the fracture stopped, which is hard to see in the video. Here is an extra long propagation saw test, or PST, done for research. When Thomas Exner drags a snow saw about 40 centimeters along a persistent weak layer, the crack propagates along the weak layer to the end of the column, and in this case, the block slides. Dave Gauthier and others calibrated the propagation saw test. They showed that when an artificial crack from a short saw cut propagates to the end of the column, as we just saw, the same layer is likely to propagate cracks on nearby slopes, and these propagating cracks can release slab avalanches on slopes that are steep enough. Here is a skier-triggered slab avalanche. Let's suppose that the skier who triggered the slab did so here. Obviously, the initial crack in the weak layer under the skier was long enough that crack propagation occurred. In each direction, the crack would have spread at upwards of 20 meters per second. This diagram shows an initial failure or crack in a weak layer in orange. The crack propagation is shown in yellow. The distinction between failure initiation and a propagating crack can help us understand the advantages and limitations of various snowpack tests. Various studies have shown that the number of taps in an extended column test or compression test or loading steps in a rich block test are indicative of the stress required for skiers or snowmobilers to start a failure in a weak layer. Generally, more taps or loading steps are required to start a failure or crack in deeper weak layers. The observation of propagation in an extended column test or propagation saw test indicate whether a weak layer or crack is likely to propagate in the nearby snowpack. The release type in the rich block test likely provides similar information about crack propagation. In small column tests, the fracture character or shear quality are correlated with crack propagation propensity, but are not true observations of propagation. A crack in a weak layer can be started by a localized dynamic load, such as a skier, snowboarder, or snowmobiler. If the crack becomes long enough, it will propagate, and if the slope is steep enough, release a slab avalanche. The number of taps in a snowpack test indicates how much stress is required to start a failure or crack in a particular weak layer, but does not tell us if that crack will spread far enough to release a slab avalanche. More recent snowpack tests, such as the extended column test or propagation saw test, indicate whether or not cracks are likely to propagate far enough to release a slab avalanche on nearby slopes where snowpack conditions are similar. This video has focused on triggering by localized dynamic loads such as skiers or snowmobilers. For natural avalanches, the initial failure in the weak layer is different. However, the subsequent propagation of a crack in a weak layer is the same. There is a separate video about deficit zones that are believed to lead to the natural release of dry slab avalanches.
Kind of cool, huh? I think the takeaway there for us is when we start thinking about snowpack and stability tests or trying to interpret all this stuff, like it's extremely complicated. And that video I think is like 7 years old, and we are still scratching the surface of really understanding like what causes avalanches to release. There's a lot of really smart people who are studying this at like PhD levels, and like every few years, new things come up and it sort of changes our understanding of it. So point being, we're not trying to get you to go out and like do all these tests and like interpret this stuff. The idea is to understand like how avalanches occur, what we need to have occur, and then like really relying on the experts, the forecasters, mainly the forecasters, to tell us like what we're supposed to be looking out for and avoiding. So
that was like a vector mechanics test right there.
Yeah. And if you think about that challenge, right? Like there are some tests that can be done for certain avalanche problems that maybe give us some insight into, is this snow in this one spot you're standing, is it likely to, do you have a weak layer? Could you initiate that failure as a skier and then test further to see like, is that failure likely to propagate? Like there's a lot of uncertainty there. There's so many variables, but especially with the problems we deal with, like there's much simpler things we can do. Like the best information we can get is like, are we seeing avalanches happening? Like, are we seeing them with our own eyes as we're going out in the field? When we go through NWAC, like are other people out there seeing avalanches happen? And when you're dealing with things like storm slabs, wind slabs, like, rather than try and do a test, can you find like a very small slope with no consequence, what we call a test slope? And can you ski over that? And like, can you trigger that thing to release? Like usually right above the skin track, I can get tons of information about the storm slab problem for that day just by these little test slopes. And then I can get a sense for like, okay, if a slope is this steep with the snowpack that feels like this, I know how it's going to behave when I take that same snowpack and apply it to bigger terrain. And so that's how we tend to deal with this stuff. But again, coming back to that cheat sheet for the problems and really just taking what the forecasters are telling us. And as we go into our planning stage, we're just going to plan to avoid the terrain that they're telling us has those avalanche problems. And the more you sort of study and understand the avalanche problems, like we talked about, like if they say there's wind slab above tree line on all aspects as a problem to look out for, if we go above tree line and find terrain that's low enough angle, are we really concerned with whether or not there's a wind slab problem there? Like if we're above tree line but skiing a 26-degree slope, like we don't even have to think about it, right? And if we take it a step further, like can we go above tree line and or go into terrain, maybe we find steep terrain in the trees that doesn't have any signs of wind effect and it's below tree line, and the forecaster said the wind slab problem is near and above tree line. Again, we don't have to worry about that avalanche problem because we're using terrain to manage our exposure there. With the wet snow problems, that's really going to be driven by, often it's time of day. So, a slope that's steep enough to slide, if it's west facing and they're saying like, hey, look out for wet, loose avalanches today. Once that slope starts to warm up and get sun, like in the morning, that slope's going to be okay. But then as the day progresses and that slope starts to get, direct sun hit to it, then suddenly there's an avalanche problem there. So we want to plan our tours just to avoid the problems that the forecasters are telling us to look out for. And then we've got to constantly be using all of our senses to look around and observe what's happening. Because a lot of those things are dynamic and change. Like in the wet snow example, that's changing throughout the day. With the wind slab example, that we could be kind of anywhere in the terrain and suddenly see signs of wind affected snow. And we just need to recognize that so we can then either avoid that snow or avoid avalanche terrain that has that snow. do y'all like, does that whole process idea make sense to you all? I mean, that's essentially what we're trying to teach. And like, obviously all these variables, it takes time and experience to put it all together. So let's wrap up. We'll take a quick run through the NWAC website. And what I'm going to do is just kind of walk you through like the resources that are on here and kind of how to navigate the website. We still have a day before we're going in the field. So the homework for y'all will be tomorrow night after 6 p.m. Go on there, read through the forecasted avalanche bulletin for Crystal, and start putting this all in the plan. And then when we show up Thursday morning, everyone should have that stuff all written down in a pretty good plan. And we discuss it as a team, you know, choose what terrain we want to avoid, and then we go on a tour. Is this website totally new to any of you?
Totally new, as in I haven't really looked at it. Yes.
Okay.
Same
Cool.
here.
No, that's
We use the app, you know, the NWAC app you download on your phone. And it essentially presents that information, but I don't go on the website really.
okay. Yeah, same thing on the app we can get to. So just to show you, in case you're going somewhere else, traveling outside of Washington, if you go to avalanche.org, this will bring up every avalanche center in the US. Similar, if you go to avalanche.ca, you'll get everything for Canada. So you can always click on these, it'll take you directly to that forecast center, but we'll focus on NWAC. So as you go on, we can see the different forecast zones, and each zone is going to have its own hazard forecast and avalanche problems. So for Crystal, we're concerned with the west slopes south, and we can click on that zone. And we're going to see right away, like from looking at the map, we're going to see the highest expected avalanche danger for that zone. And then right away, we get this bottom line. So this is kind of like, if you pay attention to nothing else, like here's the most important things you need to know. So we got wind moving snow at the mid and upper elevations, so near and above tree line. Watch out for pillow-like drifts near ridge lines, below cliffs, and maybe cross slope when loading. And we've primarily had easterly winds, which is different from our predominant wind direction is from the west or southwest. So we might see some wind slabs in maybe unusual locations. As we scroll down, now we see the hazard broken down by elevation band. So they're giving us one avalanche problem.
Can you go up
for
a little bit more when you go up to, so it shifted dramatically from moderate to high on Thursday?
Yep. We'll come back to that in a second.
Okay.
So yeah, NWAC will give us the outlook for the following day. You know, no matter where you're at too, make sure you check, like, when is the forecast issued and what period is it valid for? So some forecast centers issue an AM forecast for that day. Other ones do the night before. So make sure you know what day you're looking at, because obviously that can make a big difference if you're looking at the wrong day here. So we've got our danger scale by elevation band, and then they're going to describe the particular avalanche problem. So they're saying what type of problem, where it is in the terrain. So this avalanche rose feature, this is as if you were looking down with a bird's eye view at the top of the mountain. So this is our above tree line zone, our near tree line, and then below tree line. And so they're going to shade in where they expect to have that problem in the terrain. And then They give us the likelihood and the size. Little description of that problem type. And then we're going to want to go a little bit deeper and actually read the discussion. Like they're going to give us a lot more information. Sometimes they're going to mention avalanche problems that are like, that should be on our radar, but maybe there's a lot of uncertainty or something like there's uncertainty on the amount of snow that's coming in. So maybe they'll say like, if we get a certain amount of snow or a certain amount of sun, you know, maybe there's another avalanche problem to be looking out for. So that stuff might be kind of buried in this discussion. Media pictures are worth 1,000 words. This is often sourced from just regular users out there who send these observations in. And then, you know, quick 1-day weather summary. The observation. So this is gonna pull up any relevant observations from the public for the zone you're looking at. You could go to all observations to see more from different forecast zones and also from further back in time. We can click on that and we'll see. So these are things that like we can all submit based on what we see out there. We'll talk about that when we're in the field, but the forecasters use the data that we give them and they need it. There's only, I think there's two forecasters that take on like, you know, maybe each zone. I mean, the pretty big zones, if you look at the map, there's maybe 1 or 2 forecasters assigned to that zone. So they can't be everywhere and see everything. So they need our observations. And that could be, you saw avalanches or you did some tests or just describing the snow you saw. It could be weather, anything relevant. So in addition to the avalanche bulletin, NWAC has a really, really good weather forecasting program.
Mhm.
And so as we scroll down, you know, by zone, we're gonna see precipitation. And these amounts, this is in liquid water. So whether it falls as rain or snow, when we're talking about putting a stress on the snowpack, it doesn't really matter. But, you know, 1 inch of water, you could generally assume like a 10-to-1 ratio. So it would be 10 inches of snow.
Mhm.
Depending on whether that comes in really wet and heavy or light and fluffy, an inch of water could be 6 inches of really wet, heavy snow. It could be like 15 inches of really light snow. So the snowfall amount, while it might affect our ski quality, when we're talking about sort of stress and load on the snowpack and the potential to trigger, we're mostly worried about precipitation amounts or liquid water.
Mhm.
Snow levels get pretty important for us for reasons we can all deduce, right? Ridgeline winds, and then we can get an extended forecast. So I like to start here for my forecast and then also look at whatever other weather websites I like and just kind of compare and see like, is everything saying the same thing or is like, are different models or different weather websites saying different things? And that would just tell me there's more uncertainty in the forecast.
Is there anything on here that looks back to see how accurate the forecast was?
There's not. That's one of the trickier things about weather. It's hard to find that archive data.
Yeah, nobody wants to get fired for being wrong 50%.
Yeah. Yeah. And what we can look back at. So if we go under observations, we have 2 ways to view all the weather station data. So if you've been paying attention to the forecast, you can go and see what's happened based on the weather station data. So if we scroll down here, so we can see a couple weather stations at Paradise, Mount Rainier. we might want to zoom around, see things that are in the range. So other ski areas, other NWAC stations. And if you were to click on any of these, now we can actually see over the past 24 hours, whatever, each weather station might have different sensors. So some are going to have snow height and precipitation. Some are only going to have temperature and wind. For the ski areas, generally the wind station is going to be at the upper stations, and the snow measurements are going to be the low and mid stations. We can go back 7 days. We can put in a custom date range. And then what's really nifty is, I think, the graphs. Now we can just go back and look. Okay, we've had, in this, back on Saturday, we're starting to see like above freezing temps, dropping to near freezing overnight. And it's been a little colder. And now temps are rising again. Again, here's our liquid water precipitation. And then our total snow depth, 24-hour snow depth. And when you see these like big spikes, that's usually just, it's an anomaly. Like maybe there was some icing on the sensor or something weird like that. So you want to just kind of filter those things out. So there's a ton of information we can get on here. Another way to get to this is if you go to the list, weather station list.
Oh God.
We can go in here, and I like to actually use this now link, and that just brings me straight to the tables. So we can see total snow height. Where we see that going down, that just means that snow is settling. So when we have storms going on, that can tell us like, is that storm snow settling and becoming denser and maybe forming more of a slab? We can see the 24 hours. So this, for whatever reading here, they're going to reset this. If we look at the 7-day, we'll see where they reset it each day. So at 9 a.m. on the 9th, it was reset. They had 5 inches recorded over the previous 24 hours. And then it started snowing again. And we can see here again at 9 a.m., they reset that board. So that's a patroller going out and clearing that snowboard off and recording what was on there for the last 24 hours. Everything else should be pretty self-explanatory there.
You ever go back, get a story though, and look at the overlay and see any patterns to try to predict what you're getting? Or is it just the variables, just too many variables to kind of create patterns?
It's possible. I mean, if I were away on vacation or back in Colorado and then coming out here after a month, I might go back and look at the graphs just to get a sense of like, okay, what's generally been happening. And what I'm going to want to do is like validate what I'm already seeing in the avalanche bulletin and the snowpack summary. A great tool we have here to do that.
Seems like it's one big math equation, right? Like all
there's just so many so many variables.
Can you
question.
talk about, is it clear why, to you, knowing the forecast, why this is where we're going from yellow to red on Thursday?
Yeah, I mean, what do we know?
There's gonna be a lot of snow.
Yeah, I mean,
A lot of snow,
is it
probably a
just
lot
the
of
10 inches or
rain.
whatever that's expected?
Sorry, what was that question?
Is it just the snowfall that's expected and that it's, I mean, it seems like it's going to be pretty heavy, meaning dense and moist snow at like 32 degrees, they call it low 30s, high 20s, low 30s.
So, yeah,
Lovely.
you can always go down, you read this forecast discussion, and they're saying Wednesday is going to be kind of the last calm day. But they've had a lot of wind transport, a lot of blowing snow has been observed, and seeing like small slopes that are failing and seeing natural wind slab avalanches. So that means like, okay, there's wind slab problems out there lurking, and now we're just going to put a significant load and stress on that snowpack.
I see.
So here they say, as we head into the more significant storm, in areas down in the trees where it's sheltered, we have 2 to 3 feet of snow sitting above the old crust. And it's generally pretty settled and bonded, but it's not without the potential for weak layers here. And then now we're going to have this huge weather event. And generally, like when we start seeing precipitation of this sort coming in, like, yeah, it's going to be considerable to high danger typically, just because of that new snow coming in.
Quick question. For the table that you showed earlier, is that updated like every hour? Or
Yes.
yeah.
Yeah, that's all automated. And then there's like I said, there might be like some of the storm boards or snowboards, that might be a patroller going and actually measuring it, but most of that's all automated.
Thank you.
Trying to find, I don't know if they don't do it this year, but there used to be like a weekly kind of snowpack summary.
Freezing levels. So it looks like freezing levels coming up. Snow's imminent. So you're getting a big, heavy, wet snow on top of that layer that's already cracking.
Exactly.
I guess about freezing. The snow level's going up to about 6,500 feet. And freezing rain overnight on Thursday.
So hopefully that's kind of the main tools and resources that I use the NWAC website for. So what you can all do now is tomorrow, keep an eye on this stuff, and then stay tuned for an update on our plan. But for now, we'll plan to meet in the field on Thursday. Hopefully we can get out. Given the forecast, we're not going to be moving into like any serious terrain, but there's a lot of other things we can do without even getting into the avalanche terrain. And then we'll see what actually happens with the storm and conditions, and we'll make a game time decision for Friday. But I'll get an update out to you, and I'll have Jeff do the same by like midday tomorrow to kind of confirm that plan, just so you're not all left hanging in the dark there. But start taking like all the things we talked about today, what we now know about weather and all the changes and how that all affects the snowpack problems, and start trying to build a mental picture of like, what do we expect to see in that forecast come Thursday?
So your earlier comment about tomorrow is out, right? We're not hearing tomorrow.
So my group, the split board group, we can chat. And if everyone is like, yeah, I can totally get up tomorrow, it would be sweet to do it, but I think it's a long shot. But I want to throw that out there. And then I haven't heard from Jeff. I can send him a message right now and have him reach out to the rest of you. That sounds good.
And then I guess the question would be, if we don't go tomorrow, we go Thursday and it gets too chaotic for Friday, do we just do it next week? Is that the plan?
Yeah, at that point, the office will have to take over, and it's kind of between,
Sure.
for the group of the Langers, since you're all booked as a group and a private group, I think kind of whatever works for you all. For my group, they'll probably, if we reschedule a day, they'll send you out a list of like, here's all the days we have openings for courses for the rest of the season, and you can kind of choose which one works. The downside to that would be, I don't think there's any more split board specific courses. So you might be in with a bunch of skiers. Damn skiers. But it's just the realities. Welcome to skiing in Washington. Often our plans get stymied by the weather in some way or another. So that said, I'll send out an email to the split board group for the Langer group. From here on out, you'll hear from Jeff on all those plans.
Okay.
I'll put you in his capable hands for that. And for now, yeah, you're all free to go. Like I'll stick around for a few minutes if anyone has any more questions, or if we want to discuss that option for tomorrow.
Yeah, I have a couple of questions. I don't know if you do. I feel like I gotta catch up on a couple of questions here. So
Sure. Yeah.
Thank you, Eddie.
thank you.
Yeah.
Thank you.
all.
So Eddie, Scott and I can't make it tomorrow, so.
Okay.
Work-wise, so we're gonna have to stick with Thursday. And we're
Yeah,
fine.
I'll be able to make it too. Just
Okay. Yeah, I figured I wanted to throw out the option, but we'll just stick with Thursday, Friday, and we'll see what we can do.
Thanks, Eddie. And would it likely be like upper lot C? Where we meet at Crystal?
Stay
Or-
tuned. I'll send
Okay.
out an email tomorrow, like early tomorrow, midday, with all those details.
All
And
right,
would you expect
cool.
Jeff to do the same thing for our
Yeah.
group?
Yeah.
And what's Jeff's email? Or I mean, what is Jeff's last name? I'm sorry. That would be coming through.
Tarshis is his last name.
Arshis.
Tarshis, Tarshis.
I'll just keep an eye out for him. Mine has more to do with access. It's how you access to the site or to the training material, and the filling out of the form more than anything else. I feel like, am I missing something in what I'm not accessing on?
Were you able to get in through AIARE?
No, I've been flying all day, so I just got
Okay.
back. So I'm going to try to do that. I logged on. I just didn't seem to be able to access it. So I don't know what's going on.
Are you talking about the release form, Clark?
Well, I got to do that. I realized I have to do that. I got an email on that tonight, so I got to do that. But no, it's actually getting in, logging into the site. And then, is there training materials on the site that I'm looking for, or is it just is it just signing up for the?
There is like a whole kind of online classroom that you can go through AIARE Online, and you'll have access to it, I think, for at least the rest of the season too. So if you can get through it, or at least get through a chunk of it before Thursday,
Yeah.
you'll
Okay.
get a lot more out of the field days. But since you guys signed up last minute, I totally understand if you don't get through it all.
Oh, I might call into your office tomorrow morning then and figure out how to get onto that
Yeah.
thing. It felt like I logged in, got all my credentials, and then it kept looping me back to the same request. And I was trying to do it on the plane. So that was another joke, but,
Yeah,
so
give the office call, or I don't know what Jeff's schedule is like. I mean, I'm around tomorrow too, so I
Okay.
can help walk you through it if need be. Yeah, we'll get you squared away on that tomorrow. And then everything, once you're on there, it should be pretty user friendly to navigate.
Right.
And then everyone's gonna get on the first morning we all meet, you'll get the actual like physical field book, and that's got all the trip plans and such in there. When you go on through AIARE Online, it will have like a little PDF with an excerpt from the field book with like basically like the trip planning page. So if you want to use that as a reference to kind of walk through your prep before we meet up, you can use that.
Yeah, that's what I heard you say is listen to the forecast and start prepping your plan for Thursday morning. So I just want to make sure I have that available. So that would be online. I can grab that before we grab the books on Thursday.
Yep.
Yeah, great. Okay. All right. Well, thanks for your flexibility. I appreciate it. Sorry. It's
Yeah.
been,
No.
been a
Glad
shit
you're
show myself.
here.
Quick question, Eddie, just to get an idea on what we do in the field. So I guess how does it go in the field day? Like, you said like we're gonna go and tour, like, well, so it's from like 8 to 4, like, I guess what's the activity for that day? Do we get to ride or
Yeah, it's going to be a little
like
dependent
normally?
on conditions and weather, but typically what we do on the first day is it's a pretty easy mellow tour, and the goals are to go out, spend part of the day practicing companion rescue, and then also looking into the snowpack. So we might dig some pits to kind of see layers, if there's any layers to see, and maybe like demonstrate a couple of those tests, but just kind of practicing observations, practicing the whole planning and observations throughout the day. They're kind of ongoing obs. And then ideally the next day, it's like we turn it over to you, like the group of students. You'll kind of like lead and manage the tour, and then myself or Jeff will just be kind of there like coaching and helping apply stuff. And so usually we try and get out on more of a tour on that second day. So you can kind of see what that might be impacted by conditions.
Yeah. Thank you.
When you say impacted by conditions, do you mean avalanche danger itself, and how that would impact a tour, or are you talking about potentially that it might rain at Crystal on Friday?
I'm talking about both.
Okay.
Ideally, we like to actually get into avalanche terrain and be able to see that terrain, feel that terrain, like make real decisions in it. If hazard is too high, if it's considerable or high, that really limits where we can go. So we still can do, maybe get a tour in and make relevant decisions, but at a certain point, it's almost like we're forcing something. So
yeah.
Well, let's pray that they're wrong again on the actual weather. You mentioned in the gear that we needed the saw. I'm assuming we don't need a saw at this point.
Yeah, you don't need one.
I mean, maybe to get one, but not for this training.
Yeah,
right?
it's in that gear list more as an optional or something. I think for the level 2 it's required, because for the level 2 we're actually teaching more tests. But yeah, you don't need one, and I'll definitely have one. I know Jeff will have one, so one for the group is fine.
Tag that I mentioned, a crystal tag. What is that?
Same, kind of goes along with the saw. It's a little card where it's got like a grid for sizes, so you can actually shovel out some snow crystals and look at them.
Got it. Okay, so I'm not gonna try to find that tomorrow.
No, don't worry about that.
And then I assume we're eating lunch up on the hill, so we should plan on packing lunch. Is that right?
Yeah, normally it's like just kind of snacking throughout the day. There's quite a bit of standing around, especially on the first day. So we do like companion rescue and that stuff. So yeah, pack snacks. Thermos is nice with a hot drink, and maybe 2 or 3 Gore-Tex jackets.
Well, there's definitely no shelter up there. Ripped down all the lodges except for camels. So do they have the evil turned on up there? I don't even heard the.
Yeah, it was back on Sunday. It was back on by 1 p.m.
Jesus, what a shit show. All right.
You know, I haven't been to Crystal this year at all. I know there's like, it's kind of chaos with their whole base area and parking and all that. So especially if conditions are bad, I mean, I guess it probably won't be too crowded up there, but maybe we'll rendezvous somewhere in town where we can like sit down, have a good solid morning meeting, we can go more in depth at tour planning. Like there is some stuff we can do, kind of more extended classroom stuff.
Are you talking about in Greenwater or Enumclaw, or what are you talking about?
Either.
All right.
Enumclaw. So I'll let Jeff kind of coordinate that with you guys.
Okay.
But just, yeah, that may be an option if the weather's just really crapping out on us. There's a lot we can cover. We obviously don't want to spend the whole course just sitting around drinking coffee and talking about stuff, but there's plenty that we can do if we need to kill some time or get out of the rain.
Gotta love January in Washington.
Oh, come on. It's any month of the year.
I don't know. January usually is just the worst. I mean, then it comes back. But at least it's better than Europe right now. I tell you, they have zeros.
Yeah, they don't have any precipitation.
It's a real problem. It's a real issue over there right now. So, but it's feeding the energy crisis, I suppose.
Yeah. Yep.
All right. Well, thank you. This was good.
Yeah,
thanks.
no. Thank you guys.
Thank
Glad
you.
you-
Thursday, Clark.
What's that?
See you Thursday.
Yeah, you need to ride up there, Matt, or you?
I think I'll ride separate no matter what. I'm gonna check on our place up there and maybe go early, stay late.
Yeah, I'm gonna try to stay up for the weekend. We'll see what happens. We'll see how long that lasts.
Yeah.